So this lesson's called Collecting Like Terms, Simplifying Algebraic Expressions. So to simplify an algebraic expression, we add or subtract like terms. Okay? Oh, super. This is sometimes called collecting like terms. So like terms, so what it is, I'm just going here, okay, they are terms that have identical variables with identical exponents. So if we notice here, x to the 1, okay, so there's just a 1 in front of there, so it's 1x. This is 3x. This is negative 7x. This one right here is a quarter x. Okay, all of those are like terms. Okay. Next one. Here we have 2a. Then we have negative 5a squared. This one is 2a squared b. And this one is 9a cubed. These are not like terms. So in order for them to be like terms, they have to have the same variable. So these all have x's. And they all have to have the same degree. So since there's nothing here, these are all ones. Okay? This has an a, and this has an a, but this degree is 1, and this degree is 2. This degree is 3. Okay? And this one has a squared b, so that's why they are not like terms. Okay, so when collecting like terms, identify the like terms of each expression. Group the like terms together by rearranging, okay, and keeping the operations in front of each term. Okay, so this one's so important, keeping the operations in front of each term. So right here, see this says negative 6y, so you would keep it negative 6y. This one is negative 2x, it's a negative 2x. This one is a positive 1. This is a negative 11. This is a positive 1. Negative 2, positive 16, positive 3, negative 1, negative 5. Okay? And then last it says add or subtract according to the given operations. Okay? So when there isn't a coefficient, use a 1. So for example here, this positive m, there is no coefficient, so we're going to use a 1. This is just a 1. Okay? So that's a positive 1m. This one is a negative 1n. Okay? So let's do a couple examples together. So simplify the following algebraic expression. Now remember, I'm using this new piece of equipment, so I'm trying to write the best I can. Okay. So down here, we have 5x minus 6y minus 2x plus 1. So the first thing is we're going to identify the like terms. Okay? So what I like to do is put a box around my x's. Okay? And then I have a y, so this one's a y. That one's not a y. Okay? And that one's just a positive 1. So let's just leave them and we'll start. Now it says group the like terms together by rearranging and keeping the operations in front of each term. So let's do our x's first. So I have 5x, and then this one is a minus 2x, so minus 2x. Okay, there's no more x's, so now I'm going to gather my y. This is a negative 6y, negative 6y. No more y's, and then I just have a positive 1. Okay, should be an equal sign there. I just forgot it. Okay, so now we're going to simplify. 5x's take away 2x's gives us 3x's. And then we still have negative 6y plus 1. Negative 6y plus 1. Okay, now there's nothing else to do. We've added and subtracted everything. We have one of each term. Oops, so this is our final answer. Let's go to our next one. So I wish this could be more in the middle. I'm like writing on the half, like end of it. Okay, so anyways, here's an M. So I'll put a box around my M's. Not an N, not an N. Oh, here's an M. Not an M. Oh, here's an M. Okay, so our m's, I put boxes around. Now let's collect our n's. I'll do little squigglies. There's an n. There's an n. Positive 16, a circle. Negative 11, a circle. Okay, so what we're going to do now is we're going to collect our like terms. So we'll start with our m's. I'll do positive m, so equals m. And then, oh, we have positive 3m, so positive 3m. And then we have negative 5m, negative 5m. Okay, now let's go to our n's. Here's an n, negative 2n. Let's write negative 2n. And then negative n. And now let's go to our constants, negative 11 and positive 16. Okay, so we just grouped our like terms together. Now we're going to add or subtract according to the operations. Okay, so 1m plus 3m gives us 4m's. 4m's minus 5m's gives us negative 1m. So we have negative 1m. Okay, so that was all of these. Now we're going to look at our n's. So negative 2n, take away another n. So now we're at negative 3n's. And last but not least, our constants, 11 plus 16, or you could say 16 minus 11, and that gives us positive 5. And this is our final answer. Next frame. Okay, so I'm going to put boxes. Oh boy, that did not look good. So that's a 3x squared. Now over here we have x squared. Okay, then we'll go to our x's. Negative 5x, negative x, and then I'll just leave these constants with nothing around them just because it's hard to squeeze everything in. So we've identified our like terms. Now we're going to collect them. So 3x squared plus 2x squared plus 2x squared. Then minus 5x. And then minus x. And then our constants, plus 2 and minus 5. So now we simplify. 3x squareds plus 2 more x squareds gives us 5. Sorry, my internet cut out. 3x squareds plus 2x squareds gives us 5x squareds. Oh. It's not letting me write. 5x squareds. And then negative 5x, take away another x, gives me negative 6x. And then 2, take away 5, gives me negative 3. And that's your final answer. Last one here. Okay, so let's start with our m squareds. So m squared, that's not one, that's not one. Oh, here's one. Not one, not one, not one. Okay. Then let's do our MNs. Doesn't matter your order as long as you're collecting them all together. Okay, so that's it for that. Now let's do our N's. Do a circle around that one. So N squared. Oh, here's another one. And we'll leave our constants. Okay. So, actually, I'll do it down here a little bit just so we have a little bit more room. Just ignore that. Okay, so 6m squared minus m squared. Now let's go to our mn's. So we have 3mn. That's a positive 3mn since there's nothing there. Oh, minus 3mm. Now we have minus n squared plus 2n squared. Oh, we're getting a little short on room, plus 3. Let's do it down here. And then minus 4. Move this over. Okay, so we're going to simplify. So if you had 6m squareds and you take away 1m squared, you're left with 5m squared. Here, 3mn's, take away 3. That gives us 0mn, so you don't even have to write it. Now let's look here. Negative n squared plus 2n squared. Okay, that's going to give us positive n squared. And then last but not least, we have 3 minus 4, which gives us negative 1. So there's our final answer. Last two. So now we're going to simplify each expression, so like we were just doing, but now we're going to plug in x is going to equal negative 3 and y is going to be 2. So it's going to be just like these, only once we get to here, we're going to sub in a value for our variables. Okay? So first things first, let's collect our like terms. So, oops. X squared, there's our x, and then our constant. So, we're going to start with 3x squared minus x squared, and then minus 5x plus 4x, and then just plus 4. So now we're going to simplify. 3x squareds, take away 1x squared, gives us 2x squareds. And then negative 5x plus 4x gives you negative x. And then we just have a positive 4 at the end. Okay, so now we are going to substitute in. So this is telling us that x equals negative 3. So, right here, we're going to sub it in. And in here, we're going to sub it in. Okay, so 2 instead of x, now we have negative 3. And don't forget that it's squared. And then subtract, because that says subtract. And then where we have an x, we plug in negative 3. Okay, don't forget the bracket, because it's very easy to forget one of these negative signs, okay? And then plus 4. So now we have 2 out in front. Negative 3 squared. Negative 3 times negative 3 gives us positive 9. So that's positive 9. And this right here says, if there's nothing there, it's assumed that it's a 1, right? Negative 3 times negative 1 times negative 3 gives us positive 3. Okay, negative 1 times negative 3 is positive 3, and then plus 4. And now we have to do multiplication. So 2 times 9 gives us 18, plus 3, plus 4. And then you can use your calculator and all in one step. Let's do 18, plus 3, plus 4, and that gives us 25. So the answer is 25. Okay, now this one, we might run out of time, so I'm going to pause and put this last one on the separate video.